Proceed then. So yes, hello. My name is Steve Ingram. I actually lead solution architecture for Smartlogic, and I'm very happy that MarkLogic have given me this opportunity to present my company, the product, and how we contribute to digital acceleration. So I hope everybody's awake. If you weren't before, you are now. So I'm going to present a few slides and then demonstrate some of the capabilities of our product. I've only got 30 minutes, so I'm not sure. I don't think we'll have time for QA in my presentation, but obviously put any questions in the chat and we can pick them up at the end. So we've been around since 2006, and our tagline is revealing smarter decisions. And so this is all about making the most of your information assets, driving acceleration by making sure you, your partners and your customers extract maximum value from all the data that's lying around your organization, your ecosystem. We do this by providing a rich layer of metadata and also allowing the companies to manage their knowledge models, so taxonomies, ontologies, business glossaries, control vocabularies, in a collaborative approach that maximizes the contribution of the subject matter experts that are in your organization. We do this for tier 1 customers worldwide. You might recognize one of the logos towards the bottom left-hand side. And as we've been a MarkLogic partner since 2012, many of the larger customers are joint projects, and there are many others where we're engaged separately. But the combination of Smartlogic and MarkLogic is a very powerful one. We're actually also a MarkLogic customer. The Semaphore cloud offering is hosted on a resilient MarkLogic MarkLogic cluster. There's the common theme with all these projects and customers is it's typically text heavy, a lot of unstructured content, a lot of textual content, and typically in regulated environments. So you have to track what you're doing, what you're saying, and make sure it's compliant. So while I can show you the logos, I'm afraid I can't really go into specifics of any one of these cases, but I will be discussing 3 applications of Smartlogic and MarkLogic after my demonstration. So fundamentally, we believe that metadata is the key to value. So in the same way that you wouldn't go for a trek outdoors without taking a map with you, in the same way that metadata handled correctly describes your data landscape. And we sort of view metadata in 3 there's 3 classes. There is the sort of static metadata, you know, the file size, the create date, the source. Doesn't change much, limited value, but it's useful to have. And then there's the layer on top, which is the semantic metadata, which is describing the meaning. So who is the audience for this document? What topics are being discussed? Are there any products mentioned? And then the third category is sort of semantic metadata, which is essential for the decision-making process. So, you know, what entities are in this document? Is there any PII mentioned? Are the products that are mentioned, the combination of them, does this need to be protected from export control? So this is, you know, active semantic metadata, and all three have value. And Semaphore is around the management of that metadata and also the control of those metadata definitions. And that's one of the reasons that Gartner has marked us as a leader in the Magic Quadrant for the last. Sorry, we're in the leader area of the Gartner Magic Quadrant for metadata management for the past 4 years, and it's kind of cool to be ranked alongside and often above the likes of IBM and SAP, especially when you're our size. Now we see semantic metadata management as the key to delivering high-order applications. So on the left-hand side, you can look at managing your business glossaries, managing your reference data, and then starting to look at how you manage your model your operational systems, looking at implementing a semantic data catalog, supporting semantic search, supporting aboutness and subjective enrichment, extracting data from documents using entity extraction and semantic enrichment, powering deeper analytics, feeding it all into a metadata hub, looking at ultimately cognitive systems and indeed knowledge graphs. And these obviously are applications for which MarkLogic is a great fit. So there are 3 main capabilities within our product. So our product is called Semaphore. And these are the collaborative curation of knowledge models. So whether or not, as I said, these are taxonomies, ontologies, business glossaries, controlled vocabularies, reference data, fact extraction definitions, they are all knowledge models. They all map some part of your domain. And we represent them as in SCOS Excel format in an RDF graph. Secondly, it's the use of these models in combined with the natural language processing engine to enrich content with additional relevant and consistent metadata. And lastly, the use of these models to harmonize vocabularies across your organization, power knowledge discovery, and typically drive better decision making and deeper analytics and that kind of thing. And importantly, we're designed to do these jobs at scale. So whether that's managing, as we do for some of our customers, taxonomies with millions of concepts, processing decades of medical information, or supporting thousands of queries per hour on a retail website, this Semaphore is designed to handle precisely these kind of mission critical requirements. And all this is done with version 5 is now done from a unified browser-based server-side product. So let's look at how organizations typically deploy these capabilities. So if you're an organization, you have lots of information sources on the left-hand side, lots of audiences on the right-hand side. Some may be internal audiences, some may be external audiences. And Semaphore can work right across the board as part of what we call a semantic AI middleware platform. So if you have content that's coming in, it's unmanaged content, it's coming in from a website, or it's third-party content you wish to distribute on, we can make sure that it's matched with rich content, rich and consistent metadata. And we can also make sure that we can power semantic search over that. So we'll make sure that user queries can be mapped onto your internal ontology, and then the content that's returned will be returned because it matches that ontology or that taxonomy. Now, it's important to note Smartlogic is not a search engine. We work very happily with MarkLogic and other engines. And we are all we do is manage taxonomies and mark up content. We're agnostic as to what you do with it after that. So that's on the unmanaged content. On the managed content, obviously we can integrate with CMSs and DMSs. We can provide additional metadata. We can make recommendations, or we can provide automatic metadata over the top. And authors can also use this to choose metadata from controlled vocabulary lists. We can extend that down into data that's held within a database. So it can be, if it's text, it doesn't have to be a document. It can be free text fields in a database record. And lastly, because our ontologies are based around RDF graphs, they become an integral component of your knowledge graph initiative. So you can start with a knowledge model that we're managing through Semaphore, and then extend that with documents that contain those terms and other information as necessary. It becomes the foundation for the knowledge graph. And in terms of digital acceleration, so there's enhanced search and discovery. We're using vocabularies are harmonized, so people with different business units, different frames of reference can find the same content. So if you're working with a consumer medical environment, you're going to have patients using one set of terminology, carers using another set of terminology, doctors using a third set of terminology, and you want to be able to route them back to the content. And if it's enriched from a consistent, doesn't matter what terminology it's using, you can find that content in relation to the user query. We can match content to intent because we look at what the meaning of what a query means, as opposed to also what the meaning of the content is. And lastly, you can obviously leverage unstructured text to improve decision making. So you really can make sure that every piece of content in your organization is contributing in some way, shape, or form. So if we look at, so what would be how would that impact various people within an organization? So we've got 3 kind of example use cases we use. There's Kit, who is a consumer, he's an analyst. It could be internal, it could be external. He's going to be consuming what's the content. June is a contributor. She's going to be consuming and also contributing. And Sarah is a taxonomist. And she's actually responsible for maintaining the ontologies that the rest of the organization and the customers are using. So let's look at Kit's options. He's, as a consumer, won't be using Semaphore directly, but he will be using enriched search, semantic search. So in this situation, uh, this is just a demo. It's one of our standard demonstrations. He searched for Apollo 16, and back his content is classified as being about Apollo 16. So it's past our threshold, which you'll see when I go on to demonstrate the product. So with a high degree of confidence, it's about Apollo 16, even though the term Apollo 16 may not appear anywhere in that content. It's semantic, it's based around the meaning, not necessarily what terms appear in there. And also you can use the model to find what terms are related. So this is showing Apollo 16. So we can see from our model, we have the crew and we have the vehicle and we have the destination and other information. That's so if you didn't know anything about Apollo 16, then he can use that, use the model to navigate. And on the left-hand side, we have refiners. So this is all metadata been provided by Semaphore. And because this is all using, it's a knowledge graph, we have the concept. Everything is labeled with that ID or that URI. You can use that. So if documents are classified with different subjects or extracting different facts from those documents, you can immediately place that in context because everything carries a URI. It's all marked up correctly, and you can display it as a knowledge graph, as I think you saw with the Amgen example earlier. So that's Kit. Hopefully happy. June. As a contributor, so she's a consumer as well as a contributor, so she will be able to benefit from the same capabilities in terms of semantic search, semantic discovery, and knowledge graph in terms of being able to, and knowledge graph in this case is very useful because if you have the source material tied to your ontology, you can trace back and see key information, find the provenance of information, and you can see you get that in-depth view if you need to really deeply research something you're creating content on. But then she'll start to interact more with Semaphore when she's actually authoring content. So anything June creates can be automatically classified as part of the workflow. So rather than her think up lots of metadata items, she can do that. The machine will do it for her, or she can choose from the controlled vocabulary and populate the metadata manually. So in this way, very easy, very simply, content is better marked up, better described, and if it's got decent metadata on it, it's 50% easy, about 48% easier to find content that's got well described with accurate metadata, and we're not forcing her to do it. And secondly, she can integrate directly with Semaphore. We have something we call the knowledge review tool, and this is designed to let subject matter experts who might be authoring content also contribute directly to the model. And I'll show you how that works in the demonstration. But this does mean that poor old Sarah doesn't need to know everything about her organization. What she can do is leverage the information from the subject matter experts. So hopefully that's June. And now let's look at Sarah. So Sarah is information management specialist, experience in information architecture, information science. And her job is to maintain the ontologies which are being used by Kit and used by June and their colleagues. So she gets a lot of toys to play with. So she firstly has Semaphore Knowledge Model Manager. It's a browser-based tool for managing ontologies, and I'll be demonstrating that later. Semaphore includes what we call side panel widgets. So Smartlogic's philosophy is very much there is always a human in the loop somewhere. So because the information is going to be consumed by a human, the human is the ultimate arbitrator for what is important. So, but we provide tools to assist in the management of these models. So we have the lexical resources side panel, which uses some machine learning over 40 million Wikipedia articles. And what this does is suggest concepts that may be relevant to topics in your ontology. So you can provide additional enrichment, especially if you have, say, just a standard set of definitions and you want to make, obviously, the richer you make your model, the better the classification. And so we're providing tools to assist you with that process. We also, if you're working in a multilingual environment, we provide a translation widget. So if you have your definitions in English, you want to deploy a model to Spain or Russian-speaking customers, then we can convert the labels. The tool will convert the labels for you. Quite often we talk to customers and they say, well, I don't have an ontology in my organization. That is never the case. There's always one set of definitions. If it's in a semantic format, great, we can import it in. So if it's in SCOSXL, it'll import in. If it's SCOS, it'll import in. If it's AL, we can convert it and it'll used alongside any other definitions you provide in Semaphore. But typically these definitions are in Excel format, and we have a couple of wizards for importing ontologies, which are just Excel definitions. Sarah can use, well, as I said before, when you saw that June was able to contribute to the model, so Sarah doesn't need to learn everything about her organization. She can just manage the contribution from her users. If users have their own sets of definitions, then we have the model mapper as part of Semaphore. So definitions can be supplied by a new business unit, for example, if they want to come on stream as part of an enterprise taxonomy project. They can say, these are the definitions we use. Sarah can take that set of definitions, map it onto the existing ontologies, taxonomies, see where the overlap is, see where the disjoint is, and then adapt accordingly. I recommend a strategy for them to be incorporated. And most of all, Sarah's job is made a lot easier because people can realize the benefit they get if they maintain their taxonomy properly. They will get automatic classification. They will not have to fill in all these metadata values themselves. So very quick charge through various applications of Semaphore. Let me now actually run the product itself. So hopefully, right. So this is, hopefully you can see, welcome to Semaphore. This is my local server, demonstration server. It's running the most recent version, which is Semaphore 5.2. This is just a browser window. It's a collaborative system. I'm logged in as just as an administrator, because it's my machine and I use it for development and demo purposes. So I have full access to everything. You can partition. Obviously, we support multiple users. You can limit who can see what. You can limit the functionality people have. You can limit people to working in QA environments versus stopping them from working in the production environment. And I can, because I have access, for example, I can actually see all the servers that are running, and I could manage them from here as well. So the first thing I want to do is just demonstrate what we mean by semantic enrichment. So to do this, I'm going to run what we call the document analyzer, and this is a test tool into our classification enrichment server, which is in a deployment we'll be running in the background, processing documents from SharePoint or MarkLogic or from what other system you might be using. And I'm going to drop in, actually I'm going to open it first. So it's a Word document. It's about, it's actually a Wikipedia article on Apollo 11. And I'm going to drop it in. And I'm going to classify it against the server, which has actually been configured with the Apollo 11. Sorry, it's been configured with a space missions ontology. So on the left-hand panel, you should see the text that we've extracted from the document, and we support something like 300 document formats. This is a Word document, so you have the text we've extracted, and also we've identified a table. We're putting the table 3 rows back as well. And on the right-hand side, in this pane, we're showing you the semantic enrichment. So these are all concepts from our model. So you're seeing the concept type, so it's an astronaut, the label, John Young, and a confidence score, in this case 0.72. If you want to actually see what's coming back most, you can see that it's astronauts, NASA, Buzz Aldrin, Michael Collins, and Neil Armstrong, which is good because it's about Apollo 11. And then other definitions in various categories below. We actually look at topics, though. So we're classifying for named entities, astronauts, and organizations. We're also classifying for general topics. And we see that coming back is the concept Apollo 11, and we have a confidence score of 0.59. Now, we can query the document, and we can highlight, and we can see that it's mentioning Michael Collins, Saturn V, Buzz Aldrin, Neil Armstrong. I must have accidentally clicked a couple of things. I've got something else active, never mind. So I've got we've Michael, Neil Armstrong, Buzz Aldrin, Michael Collins, Saturn V. It's got the Apollo 11 call sign. It's got the Apollo 11 COSPAR IDs and SCN ID. But if we actually were to look at the document itself, there is no mention of Apollo 11 anywhere in this document. So it mentions Apollo more than a few times. It doesn't actually mention Apollo 11 anywhere, but because it's the crew of Apollo 11, it's talking about the launch vehicle of Apollo 11. It's using the call signs for Apollo 11. There's enough evidence in that document for us to say safely, with a confidence score of 0.59, it is about Apollo 11. So if I then had this as part of a search engine, user types Apollo 11, they will see this document. This will be returned. If I want to know more about why this classification has taken place, I can interrogate it, and I can actually see all the different labels, and I can see where the variants that are generated and where the matches are. And if I want to go into detail and perhaps edit the concept to modify something because it's overfiring perhaps, then because we're in a unified interface, I can click on here and it will now open the model that classified that document. It'll open it on the Apollo 11 concept. And I can actually now go to town and then look at the definitions and maybe make some changes if I need to. It's on my machine. It's a little bit slow, but now look, there we go. So this has gone, before we were running Document Analyzer. Now we're running, we've switched to the Knowledge Model Manager. So on the left-hand side, we have what we call the concept schemes. Some of these could be hierarchical, some of these are not. And it doesn't matter. We're not shoehorning the concept into a particular point in the hierarchy. So these can be polyhierarchical. They can be any depth. They can be any complexity. It's not a problem. This is multilingual. So we have Apollo 11 in preferred label, German, English, Spanish, French, Japanese. Alternative labels, which could be just synonyms, other ways of referring to Apollo 11, again in multiple languages. Or they could be specific and meaningful. So in this situation, because Apollo 11 is a space mission and we have a class assigned here, we have call signs, COSPAR IDs and SCN IDs. So these are alternative labels, but these have semantic meaning. An astronaut doesn't have a call sign. An astronaut might have a nickname, but a mission has a call sign. So we can actually apply meaningful labels. Underneath here is the metadata. So this can be useful for providing best bets or explanations when you're looking at doing it from a search perspective. And on the right-hand side, we have the relationships. So this is a mission. So we have a crew, spacecraft, launch vehicle, launch point. And this is all sensitive. So I wanted to add a relationship. I can just click on here. I'm going to see the relationships which are valid for a mission. So, and if I choose the in program, for example, and as I type, it'll just give me suggestions from that are meaningful for that. So I could add the Apollo space program or Apollo Soyuz test project. If I was to click here and add that, it's giving me some information as well. And I can just add that triple, add that relationship. There's a visualizer involved. We just provide you with an active view of the current concept and the related concepts. So if we wanted to wander over to Buzz Aldrin, we can go over to Buzz Aldrin. And then obviously we want to go back, we can do that. And everything is logged to history. But what I wanted to do really is show you the lexical resources side panel. So we have the side panels here, and this is an open API. You can provide your own definitions. You can integrate with your own reference systems if you want to. And we provide three widgets with Semaphore. So one is what we call is just a Wikipedia widget. So basically what it does is it take your concept, it looks it up in Wikipedia, and you could maybe drag some information from here and drop that into your model. You know, obviously you could drop it in here if you wanted to. Useful for reference data, useful for providing related concepts, may not be used for actually enriching in your model. And that's where the other two come in. So the first one, as I mentioned on the slide, Sarah can use the lexical resources side panel. So what this is an index of 40 million Wikipedia articles. And what this does is it'll take the label that the concept that you're working on, fire it into the index and to return any clusters of terminology that are likely to be related to that concept. And we have three classes. There are signpost terms. These are terms that we regard as having high correlation with the concept. Terminology clusters, perhaps slightly less confidence there, and At the bottom of the list, there are some other related clusters that come back. But we can see here we actually have a cluster around fake moon landings and hoax moon landings. So what I could do if I wanted to enrich my model in that direction, I could select those terms and then say add them under, and they'll become additional alternative labels that actually become additional evidence. And so that way, if we wanted to have content that was about fake moon landings, we could also classify that as Apollo. That would have contribute towards it being described as about Apollo 11 as well, if we wanted to. And then lastly, translation side panel. So we do have our definitions in German, English, Spanish, French, and Japanese. If I wanted to add Russian to that, I could take the English labels as a root, and I'm going to send it off to a server, and back will come the Russian translations for Apollo 11. And again, this is both a preferred label. If anybody speaks Russian, I've checked it in Google, I'm pretty certain that's right. And this is definitely on surface tranquility base, which is a translation of the English label for the call sign. And so I can now add these in if I wanted to, and it's giving me the suggestions and the concepts. This is my demo model, so I won't actually update it, but if I save that, they would be committed as additional concepts. So that's the knowledge model manager. So that's the fully functioned tool for an information scientist. But as I said earlier, one of the things behind Semaphore is it's designed to be collaborative. So we have what we call the knowledge review tool. So I'm going to log in as a less privileged user. I'm going to log in as user 1. And if I log in to the system, you will see that I have access to a small number of semantic models. And I have this is telling me that I only have read access to these models. So I can see, but I can't change any of these. I can see space missions, but that's because I have access to what we call a task, which is a controlled area of a model. So why that's more useful is we have something called the knowledge review tool, which is a simplified interface. So if I logged in here, I could go to knowledge review tool, which is a URL that you can distribute inside the organization. And I'm going to go into a task which has actually been set up to allow me to make changes. So I'm logged into user 1. I have access to this task. And then what this means is I can now make changes to the model. So if I'm a subject matter expert, I don't have to fill in a spreadsheet and send it off to the library department. I can actually actively change the model. Now, I'm not going to change anything in production, as you'll see, but I've got complete control. Well, you can also limit how much can be changed. So, for example, you may have a translation team, say a Chinese translation team or Chinese partner. You want to provide definitions for your concepts to deal with Chinese content. You can make sure the model is left as it is. They can't change anything. They can't delete anything, but they can provide additional definitions, additional Chinese labels, and without risk of damaging anything else in the system. But let's say I'm allowed to make changes. I'm trustworthy. I know what I'm doing if I'm updating space missions, and I want to add Elon Musk in there because why not? So I'm going to. It's not in the model currently, so I'm going to create a new concept. And Elon Musk, yeah, well, actually spelled the name wrong. Give him the benefit of the doubt. Next, I could translate his preferred label. I won't. I'm going to say he's an astronaut. And let's just say he's also known as money bags. Save that. Oh, maybe restart. Move on. Provide the additional metadata if I wanted to. Next, what missions was he crewed on? What's he's related to? But I'm happy with that, so I'll finish that. So Elon Musk has been created, and he's now been added to my task. But he's not been added anywhere, although he's there. So I could have added, if I'd actually attached him to a program, he would be in the model somewhere. I haven't done that, but there is, Elon Musk is now sitting in my task. Now I could carry on working, carry on fleshing that out. But what isn't happening is that isn't going into the master copy of the model. But if somebody was to, with the right level of access was to log in, so let me just open up a window, go into, actually, sorry, I'm really sorry. I should log in as administrator. I'm going to go back in as master. I just wanted to show, I forgot to show you first time around. Given that I'm an administrator, I can see a lot of models. I don't have necessarily access to all of them. Just these are the ones that have been I've been added to or I created, and there's a lot more than the limited list that you saw when I logged in as user one. But I want to go into space missions, and I want to actually see what's happening in user one's task. So let me select task.
Just while you're doing that, Steve, just let you know we're running short on time, so give you a few minutes.
Yeah, no worries. There we go. This is his change. And the first thing I'm alerted to the fact is Elon Musk has been created as a concept. And then what I can do from here is approve, accept or decline that concept. And I can also, once I'm happy with that, I can commit those changes through to the master. So it's a collaborative approach. We can bring information in from other subject matter experts. One thing, you saw with the Amgen presentation the fact extraction being used to pull metadata, pull document data from unstructured source. I'm going to just demonstrate that with a slightly different example. So this is US Treasury guidance note actually about human trafficking. And they issue these guidance notes periodically. And this has a lot of information on human tracking, but the key thing that this particular customer needs is, this is a project, is to, what they want is the red flags, which are key pieces of information. And what they want to do two things with these. They wanted to extract them from the PDF and then notify particular customers of certain clients type of particular red flags that were issued under this guidance note. And then also what they wanted to do is start to be able to surface any key trends, key features using machine learning. And obviously this is a big document. There's an awful lot of stuff in here that would be just noise to a machine learning engine. But what they really want to do is train it and play with these actual definitions themselves. So what we do is, in the same way that we're able to provide semantic enrichment, we have a special type of model, which we call a fact extraction definition. And then we process the document against that model. So again, left-hand side, you're seeing the text read from the PDF. Right-hand side, you're seeing the metadata that we've extracted. But in this situation, it's not necessarily subjective metadata. So although we have fingerprinted it and said it's a guidance note, but what the key pieces of information is what we're going to feed to the downstream systems. So we're extracting the actual guidance itself. And so we're normalizing it and say the regulator is a financial crimes enforcement network issued in 2014 under reference A008. We can also find other instances of the same pattern. So we can return information which is describing other related guidance notes. But then the meat of the application, what they really want to do is actually look at these red flags. And so we can define a pattern. And what we're basically saying is this is tabular information. We don't really care what the table looks like. We don't care where in the document the table is. But if it contains descriptive text, if it refers to institution types like credit unions, money transmitters, it's got regional information optionally, discusses various types of financial transaction, that is a red flag. And we want to surface each one of those and process them. So, and that is actually what we're doing here. And it's a declarative process. So if we wanted to be prescriptive, we could actually say specifically link the table, or we could look for specific rows. But what we want to do is saying, actually, we want to surface every row that is relevant. And in fact, you see this one has all that information. If we go lower down, we're seeing information from a different table. It's still a red flag for human trafficking. but this situation just has a description and it has an institution. There isn't, we aren't forced we're not forcing the system to return information that only has, that's the wrong one, only has, sorry, I actually can't read today. Yeah, so, it's what we want is description and institution, the region and the transaction type, additional information, and it's optional, but that's the key. So this will surface all the red flags from that PDF. And it's all driven from ontologies and taxonomies, which, so in a medical deployment, absolutely, we're reusing all the information that is already being used. I had a couple of use cases to go through, but if you think I'm out of time, I could stop there.
Yeah, I think the music's playing, unfortunately.
Right. No worries. So let me just finish with that slide. So it's easy. So it's a lot of slides, a lot of text here for a summary. But the basic point is, our mission is all around allowing businesses to tame semantics, and then use these to solve the problems that have been historically difficult, and for which MarkLogic is an excellent solution. So thank you for your patience. There are other use cases described in the slide deck, which I'll leave behind. But thank you for listening.